Okay, militia. So with our 12 gauge AR, we're gonna go out and need to do some target practice, and specifically for that range in the subframes of why we have a drum-fed, fully automatic shot 12 gauge, and the whole "don't start no problems, there won't be any problems" supersymmetry. Super determination in that thing you do in the 8-bit, but everything is at least this part of the section right here. In the visible bandwidth, a Planck's constant, dealing with some things of why the measurement is 1. It is 1. 1, 1, 1, 1. That when it's not 1, or when it's 0, that the circuit is complete. It's saying throughout here all the I current charges where I don't know answers. I'm not looking at a computer where I know it. The orbitals or the patterns or the electrons. If a hydrogen atom is the size of a basketball, then it has an atomic ring by scale of roughly a city block. I think, if I'm not mistaken, that's what that was. So you have to find the increments in machinery where it starts to do that again. All right, the second order out here would be that 4 bits, 8 bit, 16, 10, log 10 on this thing, because when you look at that inch, you'll get factors of 3 times 4, 2 times 3, 1 or 2 times 6 will give me 12, right? Where that starts to get a little weird. It gets into this 2 to 12 in inches, or excuse me, 2 to 5 on inches. That gives me the 10. What gets me 8 out here is 2 times 2 is 4. So it can only be in this kind of subframe material, and it kind of always does this, but this is what it wants to do. You'll see it up top there, how that there's at what? 2 times 7 is 14. Well, that's actually gonna put me in another increment of where this thing starts to compress up into it to a straight vertical X or Y line. And, well, you go.
This episode is supported by the Great Courses Plus.
Yeah.
The
Anyways,
Planck constant defines
leave
the
this back up
size
here,
scale at
and
which the
that's a
primitive
basic
physics of our
subframe on a
macroscopic
log 5.
reality
This is the kind of stuff
gives
when
way
I'm
to
dealing
the
with the ruler.
weirdness of the quantum
Assuming
world.
that this is just an
You
inch.
might not
Let's
expect
get everything
the
out
quantum
here.
behavior
Everything
of
but
the
an inch.
microscopic to be
25.
observable on all scales of the universe,
We only need the fourth.
but
Get it out of here.
In fact,
The fact
you
that
can see
the
effect
this
of
Cadus
quantum
fly,
behavior
or the dragonfly
even
nymph,
measure the
right?
Planck
This is
constant
the
just
spectrum
by observing the
of
color
being
of sunlight.
stretched. That is its measurements to why its type of hook pattern or system, and that might be
Zeno's famous
useful and
paradox tells
interesting
us
for
that it's
other
impossible
things
to
in
overtake
close to
a
that
tortoise.
range, but they'll have different
Run as
colors,
fast as you
patterns,
like. By the
systems,
time you reach the
times of the
tortoise's
year
initial
where this
position,
system
it'll
starts
have
to
moved
change
forward.
over a little bit at
Reach that
most.
second
We're just
position,
working it
it'll
down,
move
and
forward
that's the
again.
nature of just the
To
inch.
overtake a
On
tortoise, you
the
need to
eighth
travel
of an
to its
inch
previous
is actually
position
got some
infinite
subparts to it.
times.
When I'm thinking about,
Each of those
well,
steps is
there's
shorter than the last,
8 whole
but there are
units,
still an
but
infinite
7
number.
lines that make that up, and actually
There are a few
9
problems with this
that
paradox,
determine its
but one
IDOD
is that it
in such a way
assumes
that I could say the whole thing is
infinitely
quantified. The
divisible.
whole thing is within the
This is not
globular
true.
circle of
As your
radiance
distance to
that
the tortoise
determine
becomes
first why
unthinkably small,
against something. If I
there
knew the
arises
answer,
a
that's what it
quantum
is. I don't need to
uncertainty
break
in your
down its
location.
measurements in any
Get
part
close
of the
enough to it,
lifespan
and this
there.
quantum
I start in the
blurriness
operation
means it's
between
impossible to say
7
whether
and
your
8 and 9,
location is
right?
really
That's the first
behind
hour of the
or in
day.
front
This
of
is
the
the
tortoise.
LBSs,
We
or
talked about
excuse
this
me,
recently when we
LSBs
discussed the de Broglie
of
wavelength. This, and more formally,
CDC.
the Heisenberg uncertainty
and
principle,
doing flies,
describes the
CDC,
smallest
UV,
distance
right?
for which an object's location can be meaningfully defined.
So that's real good. When we get
Tiny
into it
Planck
here, and I
constant
talk a little bit
at
more about it, but
6.63
here's some old work of mine about why this prime pattern, why this measurement is always 45 on the inch. This is all quarter inched out from old work that I did in different combinations, starting in the center, starting in a chord. See what if it does combinations and permutations of this Horseman code. Here, 2630 by all of them. You know, we go through this logarithmically. 2, 1, the triangulation. The computer does that real easy once you get it programmed. Oh, well, you're going this way, X is Y, negative from there, I negative, or excuse me, negative 4 I squared or 2, because there's symmetries to that diode, or excuse me, that circuit. And you'll see some stuff in here. Hopefully I gave you some nice little simple ones where you start to see this curvature happen. this
Even on our
this
scale,
ball wave start to
for
correlate.
example,
Now me, it's just real
along with the
simple.
sun's
This has got
temperature,
quadrants. It's got
this
that
sets the
rectifier
colour of
because I
sunlight.
choose to do this point
If the Planck
to this
constant
point,
were
not this point,
25% smaller,
not this point, not
the
this
sun
point.
would be
This point to this
violet,
one is one of
or else
those
we'd be-
rules to T
In fact, the mystery of why
We'll
hot
get back to
things
that.
glow the colour that
to
they do led us to discover
here.
the quantum
I'm using
universe in
delta
the first
A,
place.
gravity, E,
Science fact.
whatever we're doing.
Everything
We'll
in
get
the
back into
universe
that here in a minute.
glows with the light of
But
its
we'll
own
eventually say
internal
that that
radiance.
is at
Heat
this
is just the energy
breakdown,
in the random
right?
motion of
Because
particles comprising
0 and 1.
accelerating
Where's
charges
my
produce
graph
electromagnetic
here?
radiation, light,
Yes.
and so an object
No.
made of jiggling charged particles,
I didn't do
like
the right picture.
electrons
Ah,
and
yes, here.
protons,
Okay, so
glows.
these will start to stack.
Hotter an object
You'll start to see some
faster
pattern
its
space,
particles
and then
get
draw it
cooled.
out. I recommend
And so
this
the
practice.
average
This is a nice,
frequency of the
clean way to do it, to
resulting
show you
particles
what's kind of happening in the jiggle. This
increases
perfect
with
number
temperature.
here, 1 times.
This average
If you want to start with
frequency
0,
defines
but
the
that'll
colour that we
eventually
see.
just stack over.
The sun is
4,
yellow
6. You
because
keep
its
that going. That
6,000
would be the
Kelvin
next
surface
system inside of here.
produces more
4, 6,
photons
9.
in the
4,
green
6,
yellow
9.
part of the
They.
electromagnetic spectrum
What
than
type of
anywhere else.
pattern we did
Blue supergiant
relative
star
to its
Rigel
measurements
is
on
12,000
what space is doing?
Kelvin, and so it
Just
pumps out
space, a
lots of
unit. This
high
could be in it.
frequency
It could
blue
take up a,
light and even more
fractal
ultraviolets.
percentage of the amount.
Your temperature is around 310 Kelvin, so your heat glow is mostly in low frequency
Where are we going
infrared photons.
Okay,
It
so
was
this
Sir
is me
Isaac
dealing with the bus driver, and I'm
analyzed
talking
this
about that
heat
kind
glow
of
in
stuff, and
1660s.
your danger
Used a
noodles.
prism
You don't need a
to
lot of them.
split
You just need
sunlight into its component colors.
them.
He didn't realize that the relative
These
brightness
run
of
speeds
those
on inches. I'm
colors
not breaking inches. I'm trying not to do more elements on the periodic table. There are ranges where if the element was X and I needed those compositions finally homogenized at the atomic level in a process to do this, it's going to take some measurements. It's going to, here, human quantifiable run speeds and timelines. What's an inch? My thumb. What's a foot? My foot. Epsilon, right? This wave function here, let's see what I did here. 1 mile an hour, 2 mile, or excuse me, 0.5, 1, 2, 3, 4, 5, 6, 8, 10. Now that's weird. Why did I do that? Why didn't I just keep going? Well, I wanted to make sure I got these on hitting that frequency on this third break, which is 0.5, 1, 2, 3, 4, 5. In that system, and what we're doing here to this little town spots, QEDs, Alive, Thrive, whatever, this is what our organism looks like. This is the parts that most common, sure, the housing, which is a part of that. It's going to present in the what type of Wikipedia breakdown, wave function, algebra problem I set up to say whether that's accurate now, whether this situation, being the action at spooky distance, is something I can replace somewhere else. Equally to, let's go back up here for a minute, if 30 to 40K, and what averages and numbers, how many E7s do I need, or E8s do I need at 62K, 30 or 50K, 40K, in this E4 specialist, kind of been around for a while in the shop, to your work numbers. Okay, function of the dominion, function of bones, obviously. And this is kind of the what we're doing, part-time labor. If you just think about this, what is a 20-hour week? That's the simplest increment I can give you. It's half of what the real loads do. 2 measurements that happened in space. One of the averages, real over averages every year, get you closer to nearer John the Warrior Poet. It gets you nearer. So what am I talking about here? Well, I'm saying, well, in this structure, E2s and E3s and rank structures of the functions that we're applying to this system that says you're doing an integral of X, that's 1 putting rocks on a pallet, 4 by 4 by 36 inches, 1 an hour, roughly is our wave function dinos system over 1 hour. Pallets, $13 an hour, 15 and 18. Why? Because, well, if I got one like that, I could do time equity in such a way that gives me the ability to say that's doable when we do the CPI and stuff later, right? And so that's really all you're doing. And I can tell that in the grammatics of vibrations here to this closed surface integral of what these levels are doing comparatively to this closed circuit integral. It's still doing function of the dominion here, but it allows me to bones and sharps this, right? Because then quadrants here still gives me run speed, feet speeds, systems that tell me if mathematics and calculations win wars.
Now, Max Planck didn't originally